Hello everyone, myself Hans. Today we are going to solve the problem of vector calculus. Here in the question, a fluid motion is given by V vector. Is the motion is rotational, and if the rotational, then find the velocity potential. Let's solve the problem. Given fluid motion is given by V vector of y sin z minus of sin x I cap plus x sin z plus of 2yz j cap plus of xy cos z plus y square k cap. In the given question, said the given motion is irrotational. We have to first prove that we have to first so that given motion is irrotational and irrotational, we have to find del cross of v vector is equal to 0. If 0 is comes, then we have to set the given vector field, given motion is irrotational. Further in the question, then said if the irrotational, then find velocity potential, that is velocity potential, and it is denoted by phi. First we have to show the given motion is irrotational, then we have to find velocity potential. Then first we have to find del cross of p vector is equal to, this is I cap and this is j cap and this is k cap. This is del upon del x and del upon del y and del upon of del z. For I cap, here is y sin z minus of sin x, and for j cap this is x sin z plus of 2yz, and for k cap this is, for k cap, that is xy cos z plus of y square. We have to solve this. First we have to open with respect to column 1, that is I cap, that is we have to suppose to be this column is eliminated. Further we have to take operation with j cap and k cap, that is del y. We have to suppose I cap is to be eliminated, we have to take operation with j cap and k cap. Then we have to cross multiply with this del y of xy cos z plus of y square and minus of del upon del z. This is x sin z plus of 2yz. For j cap, when we open with the columns again j cap, then we have to suppose j cap is eliminated and we have to take operation between I and k cap, that is del upon del x and del upon del x. This is xy cos z plus of y square and minus of del upon del z, and this is y sin z y sin z minus of sin x. This is j cap, and further we have to open for k cap. Then we have to suppose column 3 is eliminated, and we have to take operation between I and j. Place of k cap, and from here we have to take operation between I and j, that is del upon del x. This is x sin z plus of 2yz and minus of del upon del y, and this is y sin z minus of sin x. Further we have to solve, that is differentiating xy cos z plus y square with respect to del y, with respect to y, that is here is x and cos z is taking constant, that is x cos z, and we have to differentiating partially with respect to y, with y that is 1, and plus of, and again differentiating y square with respect to y, that is plus of 2y, and this is I cap. Further, once again, here is when differentiating x sin z plus 2iz with respect to z, that is here is x taking constant, and sin z differentiating with respect to z, that is of minus of sin z differentiating with respect to z, that is cos z, and minus is already present, that is x cos z, and from here 2y plus of 2iz differentiating with respect to z, taking y as a constant, that is plus of 2z, and minus is multiplying with, that is minus of, once again 2yz differentiating partially with respect to z, that is plus of 2y, and minus multiplying, that is minus of 2y. This is I cap, and when taking this side, this is minus of j cap, that is differentiating xy cos z plus y square with respect to x, taking as a y and z as a constant, that is y cos z is constant, and we have to differentiate x with respect to x, that is 1, and here is y square with respect to x, this is 0, and minus of y sin z minus of sin x differentiating partially with respect to z, taking y as a constant, that is sin z differentiating with respect to z, that is cos z, that is minus of cos z minus of y cos z, and sin x is 0. Further we have to solve for k cap, differentiating x sin z plus 2yz with respect to x, that is taking z as a constant, that is x differentiating with respect to x, that is 1, then remaining is sin z, and from here plus of 2iz differentiating with respect to x, that is 0, minus of y sin z differentiating with respect to y, taking z as a constant, and y differentiating with respect to y, that is 1, this is minus of sin z, and minus of sin x differentiating with respect to y, this is 0. Further we have to solve, that is here is minus of 2y and plus of 2y is cancelled out, and plus of minus of x cos z and plus of x cos z is cancelled out, then the remaining is 0 I cap, and for here that is y cos z minus plus of y cos z is 0, this is also minus of 0 j cap, and from here sin z minus sin z minus of sin z, that is this is also 0, plus of 0k, and we can also write equal to 0. Here the curl of the given fluid motion is 0, so we have to say that the given fluid motion is irrotational. This is proved. Further we have to find the velocity potential once again. Further we have to find velocity potential. We know that vector v is equal to del phi, and we can also write that is d phi is equal to del phi upon del x, and this is dx plus of del phi upon del y, and this is dy plus of del phi upon del z, this is dz. For partial differentiation, and we can also write that is del phi upon del x I cap plus of del phi upon del y j cap plus of del phi upon del z k cap into here is I cap dx plus j cap dy plus of k cap dz. When multiplying this we get the same, and further we have to also write that is d phi is equal to del upon del I cap plus of del upon del y j cap plus of del upon del z k cap into phi, and here is I dx plus of j dy plus of k cap dz. And from here we know that del upon del x I cap plus del upon del y j cap and plus of del upon del z k cap is given. This is equal to del is equal to given by del upon del x I cap plus of del upon del y j cap plus of del upon del z k cap. So we have to write in place of del, that is d phi is equal to del phi, and here is I dx plus of j dy plus of k dz. And further we have to earlier know that the v vector is equal to del phi. So we have to put here in place of del phi, that is v vector I dx plus of j cap dy plus of k cap dz. And we have to put the value of v vector here. We have to put the value of vector v, that is d phi is equal to, we have to put the value that is y sin z minus of sin x I cap plus of x sin z plus 2yz j cap plus of xy cos z plus of y square k cap, and here is into the multiplication, that is I cap dx plus of j cap dy and plus of k cap dz. And we have to solve further, that is d phi is equal to, here is y sin z minus of sin x into dx plus of x sin z plus 2yz into dy and plus of xy cos z plus y square into dz. Further we have to solve. We can also write in the form of, that is, d phi is equal to y sin x dx minus of sin x dx, and here is plus of x sin z dy plus of 2yz dy plus of xy cos z dz and plus of y square dz. And we have to arrange for integration. That is d phi is equal to, we can write here, that is, once again, y sin x dx, y sin x dx, and plus of x sin z dy, and plus of, we have to take in one bracket, plus of xy cos z dz, and remaining is minus of sin x dx and plus of y square dz and plus of 2yz dy in one bracket. Further we have to integrate both the sides. Then integration of d phi is given by phi, and from here this is the, we can also write in the form of, that is, xy we can also write that xy sin, this is sin x, we can also write it is xy sin x. On integration, this is the, on differentiation we get the same, integration is the opposite of differentiation, and minus of sin x dx, that is cos x plus of, on integration of y square dz plus 2y z is given by, once again is given by y square z. We have to take we have to check on differentiation we get the same above or not, that is xy sin x, taking sin x as the first function and xy is the second function. Z y sin z, here is z, here is z, some mistake is written here, here is z, this is z, and here is the answer xy sin z. On taking xy is the second function and sin x is the first function, on differentiation we get the above, then we have to set that the integration of the differentiation of this part is, we get same. On integration, here we have to put the sign of integration and we get the above result. Differentiation is the opposite of integration, that is sin x is taken as first and differentiation of second function, that is, this is sin z and xy plus of xy and differentiation of dy dx of sin z, and from here we have to write, that is sin z, and from here we have to taking x is the first function and y is the second function, that is x dy plus of y dx and plus of xy, on it xy is the first function sin z, differentiating with respect to z. Here is sin z is differentiating, that is cos z and dz. Then further we have to x sin z dy plus of y sin z dx plus of, here y sin z dx and x sin z dy plus of xy cos dz. We get the above result because the differentiation is the inverse process of integration. So we have to write in the bracket position, we have to write this is the integration of this, and sin x we have to know cos x, and y square dz and plus of 2y z dy is written as y z. This is the required solution of the given problem. Thank you class and thank you for watching.